Hey, everybody. Thanks for introducing me, Ron. I'm here with Darktrace. I'm a cyber technologist and team lead with the company, so I'm working with clients all the time, whether it's post-sales or pre-sales. And today I want to talk about using AI to respond to certain threats that are happening, and specifically how we can do that at the endpoint level. So let's get into this presentation here today. So to give you a brief rundown of Darktrace, we specialize in using machine learning to detect threats as well as respond to them autonomously. We IPO'd in April of 2021. You can see us on the London Stock Exchange at Dark. And since then, we've increased our research and development team by 48% and increased our core development team by 100%. So you can see here that we got 6,500 customers over 110 different countries with 70 different patents. So we've seen it all. And recently, within the last year or so, even more than that, we've really been focusing on the endpoint portion of security. So our understanding of the threat landscape right now is that we're seeing trends towards geopolitical cyber conflict, which shouldn't come as a surprise to any of us with the recent events. And we're seeing a lot of software supply chain attacks going off of that. So we have like the SolarWinds attack, we have Kaseya, we have Log4j, all attacks that Darktrace was able to see and respond to. And then we have insider threat, which is huge with the increase of people working remotely. And then we also have ransomware, which is going to continue to evolve in various ways and take different turns, with each step that it keeps evolving. So with that being said, with all these attacks starting to evolve, we're seeing that 78% of IT professionals lack confidence in their company's security posture. And we see that 22% of these professionals say that they lack visibility. Now, why do we think that? We think that because a lot of the tools that these organizations are using are stuck in the past. So they're relying on rules and signatures. They're more retrospective. They're studying the attacks that have already happened rather than taking into account the attacks that are currently evolving and currently being worked on. And then also just the lack of visibility, lack of information these tools have. They're not relying on raw network traffic like Darktrace does, therefore they're not able to get as granular as we can. These legacy tools, we see that fail their clients quite often. Sometimes the tool will only do detection or very little above that level, such as responding to a threat but not necessarily taking care of it, or the response will be a little bit too aggressive, such as just simply quarantining a device or taking it off of the network, which can disrupt business cases, or it'll make the client a little bit too concerned to actually enable that tool if the approach is too aggressive. At Darktrace, what we're trying to do for anybody that's working with us is we're trying to take precise approaches to mitigating threats so that you feel comfortable embracing the tool on your network and allowing it to do its job. So if we take a quick look here, here's a simple diagram that just goes to show our philosophy here at Darktrace, that we're detecting alerts, and then we're also part of our cycle of investigating is to respond. So we detect, and then within seconds we respond. A quick breakdown of Darktrace is that we're getting the traffic from places. It can be API authorization, it can be through syslogs, it can be through a port nearing session, and we use all that information to detect. And whatever we can detect, we can respond on. By default, we use Angelbeat to only respond on very critical activity, but anything that we're detecting, we can actually respond on. So that's a quick visualization of our cycle here. Detecting with all the information that we have, and then responding to it with that Angelbeat component. And this is all, this can be done, at the network level, at the SaaS level, and most importantly, at the endpoint level. So let's talk about autonomous response in the endpoint. So, Angelbeat is our decision-making brain that's taking targeted attacks to neutralize attacks. So what we can see here is that to do this, we're taking in the thousands of connections that we have at our disposal, and we're processing them, and we're looking for irregular patterns of life. So if you have a user out there, let's just say out in California, and maybe they go, to work remote somewhere, and they log in from somewhere rare, that's going to start our investigation process to see that, okay, they're at a location that we've never seen them at. And then once they start going to anomalous endpoints, external IP addresses that we've never seen before, we're going to put 2 and 2 together to say, hey, that's not really common. We're detecting that the fact that this isn't common. Now let's take an action. Let's use that autonomous response to mitigate this possible threat. Now, along with that, we're also taking into consideration what is expected for this user. So we're not going to block what's expected, what's normal for this user. We're going to allow them to do all of those regular business functions that they usually do. But what we're going to do is block the stuff that seems suspicious. This allows us to allow business to keep operating smoothly while stopping any possible threats. Now, going off of this, Darktrace for endpoint, we can do this with our C-sensor agent. So this is an agent that can be deployed on any Linux, Mac or Windows device. And from there, once that's deployed, we're able to send all of that traffic to your central Darktrace deployment, where the machine learning can be used to make decisions on what to block for the device that it's currently monitoring. So once that C-sensor agent is deployed, it will start to model that device, and it will start to compare it to the rest of the network. So it's really nice to see that, people that have been with Darktrace for a couple of years, they have all this machine learning for their on-prem network, for their SaaS environment, for their email. Once they deploy the endpoint agent, all of that information is supplementing what they already have, and the decisions that's being made on that device that's now being monitored, it's feeding off of the information that we've been taking for the last couple of years. So it all integrates quite seamlessly. So, in addition to endpoint, I'll just throw out there that we do have autonomous response for email, network, cloud, and SaaS. Then here's visualization to show more of what we integrate with specifically. So, if we want to, take an example here of what it would look like for a user that has the C sensor deployed on their laptop, we can start with a example here to the left. So, if somebody were to click a link that would download an executable to their laptop, if they didn't have Antigena, that executable would be able to be downloaded, and then from there, their device would be infected. But with Antigena on the endpoint, we could block that executable from being downloaded. And we would do that based on seeing that the endpoint that they're downloading from is anomalous, as well as the fact that they're downloading anything at a specific time is anomalous, assuming that it's irregular for the pattern that we have modeled for that user. Now, let's just say this person didn't have Antigena and they were able to download the executable, but then we turned Antigena on. The device would start attempting to do a command and control attack. It would be infected and it's trying to reach out to external endpoints to see what it can successfully communicate with. It would be able to do that if it didn't have Antigena. But if we had Antigena with the C sensor on, we would be able to see those connections, and then we would be able to just block the connections to those abnormal external endpoints. So this user could go everywhere else on the internet, but this device wouldn't be able to communicate with these command and control endpoints. Now, let's just say we didn't have Antigena, so this attack went on, and now the device is infected. It's also sending out information to these command and control endpoints. But now the infection has grown greater. Now the attacker wants to upload a bunch of sensitive documents onto OneDrive. What would happen there is that would be able to go through. But if we had Antigena with the C sensor, we could just block all connections to third-party file storage sites. So we could say, okay, we don't want this device going to any third-party file storage sites, but we need it to do everything else, so therefore we can allow that. Simply put, what's key to understand is that Antigena is always trying to allow as much valid business case as possible while stopping any possible attack. Now, to clarify, for very serious attacks like ransomware, we do quarantine the whole device, and we have the ability to do that. But our machine learning is so advanced that we feel like we can appropriately respond surgically to emerging attacks on a device. So here's another one that we were able to detect, and this one's tough to pronounce, but I believe it's Angelbeat. And this was a ransomware as a service. So this might have been 2020 or 2021. And this was ransomware that was being sold on the dark web. And when you bought it, you could actually get a help center at your call in case you needed anything. So you could purposely attack somebody, and you had a whole support system to do that. And how this ransomware was set up is that it was taking information, and before it was encrypting it, it was actually stealing it and hosting it somewhere, and then it would encrypt it. And then the ransom would be, one, to get your information back, and two, not to have it leaked. So this was a very severe strain of ransomware, and it actually, I believe, got over 100 million profits within 2020 or 2021. And what's important to note here is that at every level this attack got carried out, Darktrace had an alert for it. So although the client that got attacked did not have Antigena running, so they weren't able to respond, we were able to see the alerts that were currently taking place as they were infected with the strain of ransomware. So we were able to see when weird credentials were being used. We were able to see when scanning was being done. We were able to see when data was leaving the network. We were able to see, when weird protocols were being used or weird web activity was being used as well. All of this type of activity could have been blocked by Antigena at the endpoint level or on the on-prem network. But unfortunately, these people didn't have Antigena, so the attack was alerted to, but it was not ultimately stopped.
Hey, Dillon, one good question from Dennis centers around how do you go about determining what's a sensitive document? Are there some algorithms where you could see if it's got financial data, social security numbers, things like that?
Yeah, fantastic question. So we have a dedicated model development team that's always working on the models that detect what is sensitive information. But I would say by default, what we start with is we have a very advanced series of regex patterns that we're looking out for within the models. Not to bore anybody on the call, but that's how it starts out with. And then you work with your account team to customize those. So you would tell your cyber technologist like me, hey, I want to customize these in this way to look for these certain file names. And then anytime those file names are seen in the connection header, we can either alert you to that activity or block that activity. If there's any follow-up questions, I'll be glad to answer those after I finish these couple of slides. But great question.
And what I'll do is also, Dennis, I'll connect you with Dillon through an email after the event so you can get more customized response to your organization. Let me get back to you, Dillon.
Yeah, for sure. Thank you. So, I talked about endpoint. I want to focus on that, but I also like to highlight that, it's really cool as we see things moving to the cloud and things, people are trying to, stay more remote, is that Darktrace can complement all of your switches to the endpoints as well as your switches to the cloud. So as you start to adapt in that way, we can cover any frontier. And here's just some more cloud platforms or SaaS platforms that we integrate with. So if you have people that aren't coming into the office at all, they have a laptop that they keep at their house 24/7. They're relying on SaaS as well as using like a VPN connection to get in. We can cover that at any time, anywhere. And then here's just a good story to tell to, wrap things up is that, we've had a lot of good finds recently with crypto mining malware. Obviously, this has become trendier over the past year or so. So we actually saw a junior DevOps engineer accidentally download an update with crypto mining malware. And we had a dedicated model that was looking for crypto mining. So this was really cool to see that we were specifically looking out for this type of activity, and we were able to use machine learning to say, hey, in addition to this activity happening, it's also very rare. So we could see that the external command and control server, that beaconing that was happening to it, we were able to say, okay, this has never happened before. And then we could also use our AI engine to see that it was 20 cloud servers in under 15 seconds. And we have a tool called the Cyber AI Analyst that actually does that calculation for you. So, when we say, okay, you got 20 cloud servers in under 15 seconds, that's a stat that's just pulled directly from the tool, automatically doing investigations for you. And then from there, if I had access to a demo, I could show you how we would go into the stages of the infection and how Darktrace can break that down for you, almost like your personal analyst as your right-hand man. And then obviously our Antigena component, as I said earlier, that autonomous response, we save it for the most critical activity. So we would have used it in this case, and we would have been able to just shut down all the connections associated with this crypto mining. And then we would have been able to allow this junior DevOps engineer to keep doing their regular job. So, an attack like this is probably running in the background, and the junior DevOps person probably won't notice it. So it's nice that we can block this threat. We'll block the connections. They won't even notice that their machine is being tampered with. And then they will be able to do their job, which means that you won't have to deal with a device that has been simply quarantined or something like that. That'll save up time in your day while mitigating threats. Then, almost done here. Just to keep this simple. Ron, sorry, were you going to say something?
Yeah, we got about 1 minute. So this is a perfect summary slide.
Perfect. So, a lot of people bringing in autonomous response to the network, to the endpoints. There's a, kind of trust that needs to be built, and we completely understand that. So we have a lot of different ways of enabling Antigena. We started with passive mode, which is where you just see the alerts. There's no ability for action to take place. Then we turn it on in human confirmation mode, which is where you can see the alerts, and then you can enable the alert yourself. So it'll say, do you want to block this device from doing XYZ? You can do that. And then with autonomous mode, that's when Antigena is doing all the work for you. But within autonomous mode, it's very scalable. We can turn it on for certain segments of the network, or we can work with a schedule. We could say, hey, let's just do it on the weekends. So when people are here Monday through Friday, human confirmation mode, autonomous mode, let's just save that for the weekends. And then we can also do it based on activity. So you can bring in autonomous mode, but you can say, hey, like data exfiltration, let's leave that in human confirmation mode now. But for all the ransomware models, let's keep autonomous mode on because that's so critical. We can do that as well. Overall, scalable tool. Your team can work you on bringing autonomous mode slowly into the environment. So that's all I want to talk about today.